Hi everyone, welcome back. So, in the last session, we were discussing about inter-process communication. We saw what is client-server architecture. We saw about the two different mechanisms for inter-process communication, that is, shared memory access and message passing. So, in this session, we will see what are the different methods for inter-process communication. So we will be seeing the different techniques like pipes, mailboxes, message queues, semaphores, remote procedure call, etc. Let's look into the details. So the first topic we are going to see is pipes. So we will see what is this concept of pipes, how is it implemented, what's architecture, and what are the important features of pipes. Let's go into details. So pipes, they are considered as a conduit for information flow. Conduit means it's a channel for information flow. So as in a normal pipe, it has two ends, and pipes support unidirectional and bidirectional flow of information. It is basically a section of the shared memory which is used by the processors for communicating between them. We can find that it follows the client-server architecture. So there is a pipe server and a pipe client. So what's a pipe server? A pipe server is a process which creates the pipe, and a pipe client is a process which connects to a pipe. So let's see an example. Here we can see two processes P1 and P2, and they want to communicate with each other. So there is a pipe connecting them. So we can see P1 has a terminal for writing the data, and P2 process has a terminal for reading the data. So this is a unidirectional pipe where process 1 can communicate to process 2. Now we will see a bidirectional pipe. Here we can see process P1 has two terminals, one for reading and one for writing. Similarly, we can see process 2, P2, which also has two terminals, one for reading and one for writing. What we can find here is that the read terminals of process 1 and process 2, they are connected to the same end of the pipe. Similarly, the write terminals of process P1 and P2, they are connected to the same end. So we can find that data can flow from P1 to P2 and vice versa. When process 1, P1 wants to communicate to P2, it will write the data on the pipe with the write terminal, and process P2 will read it from the read terminal. When process P2 wants to write the data to process P1, then process P2 will write the data using its write terminal, and P2 will read the data to the read terminal. So pipes support bidirectional flow of information. Now the implementation of pipe is operating system dependent. So for each operating system, there is a different method of implementation. So in Microsoft operating system, we can find that there are two types of pipes. One is anonymous pipe and other is named pipe, which is also known as FIFO, first in, first out. So anonymous pipe is an unnamed pipe which support only unidirectional flow of information. Named pipes, they are named, they can support both unidirectional and bidirectional flow of information, and any process can act as a client or a server. So thus it allows point-to-point communication. Not only that, these two processes can be in the same CPU or they can be in different machines which are interconnected through a network. So summarizing, we saw what is a pipe, what is its architecture consisting of a pipe client, a pipe server and a pipe, how it functions for unidirectional flow of data and bidirectional flow of data, and how it is implemented in Microsoft operating system. Next topic we are going to handle is message queues. So we will look into what's a message queue, what are its features, what is the architecture of a message queue, and how it is implemented. Let's see the details. So a message queue implements inter-process communication by posting message to a first in, first out queue. For this, it uses functions like send, receive, etc. Now let's see the architecture. As seen in the figure, there are producer, consumers, and a message queue. So client application which sends the message or creates the message is called a producer. And those applications which receive the message and process them, they are called consumers. The message queue is a first in, first out queue. That means the messages that are received first will be delivered first. And they will be stored in the queue till the consumer requests for that or the consumer receives the message. Now let's see what are the features. Now a message, or it might be a message pointer. So it's the operating system which helps to insert and delete the message or the message pointer. And every message or a message pointer requires a queue. So a queue has to be initialized first before sending the message. And such a queue will have an ID. And each queue has a user-defined size in bytes. So when an operating system calls to insert a message to the queue, it will look into the number of bytes pointed. For example, if it's an integer variable as a pointer, then it will allocate 4 bytes for a single message or for a call. Now, if the queue becomes full, it will raise an error message. Now let's see something about the implementation of a message queue. The operating system provides IPC functions like create, post, post friend, flush, accept, query for using the message queues. And they can take different arguments, and one argument can be for timeout. So pend function can have timeout argument. Now we saw that when the queue is full, it raises error. So error pointer can also be given as an argument for the function. But the entire implementation will be OS dependent, and it will be different for different operating systems. Next we will see how it is implemented in 3 different operating systems. We will see how message queues are implemented in Windows operating system, in VxWorks, and real-time operating system. Let's go into Windows XP. So in Windows XP, we can find that there's a system message queue. It's a common facility, and there is a message queue specific to each thread. So a process or a thread which wants to communicate with another process posts the message to the message queue, system message queue. And the kernel will pick up this message, it will find the destination and post this message in the thread specific message queue or in the message queue specific to the destination thread or process. So this is how it works in the Windows XP operating system, where there's a system message queue and a thread specific message queue. The second case we are seeing is VxWorks operating system. In VxWorks, message queue is the primary method of inter-process communication. So it supports a two-way communication of messages with variable lengths. So the two-way messaging system is implemented using one message queue for incoming messages and another message queue for outgoing messages. So this helps in task-to-task communication as well as task to interrupt service routine communication. So this is how it is implemented in VxWorks. Thirdly, we will see how it is in an RTOS. In an RTOS, there is an option to have a priority queue or a FIFO queue. So if it is a priority queue, then all other messages will be deleted. The message queue will be deleted because the message that is coming has the highest priority and that has to be serviced first. If the other option is selected, that is it's a FIFO queue, it works like a normal queue. The one who is there, the message that is there for the longer time, it will be deleted. So this is how it happens in a real-time operating system. Now let's see the two types of message queues. So based on the behavior of message posting thread, there are two types of messaging. One is asynchronous messaging and other is synchronous messaging. Asynchronous messaging just posts the message and will not wait for the acceptance. It will go for the next process and so on. Whereas in synchronous messaging, when a process posts the message, it enters into a waiting state where it waits for a reply. So it waits for the message result and then only it will move further. So these are the two types of message queues. So we have seen what a message queue is, what is its architecture, what are its features. We saw the message queue in Windows XP, we saw in VxWorks and RTOS. And we saw what are the two different types of messaging. Now we are going to see another type of implementation of inter-process communication called mailboxes. So we will see what a mailbox is, what is its architecture, how does it work, and what are its features. Let's see that. So a mailbox is an alternate of message queue, and it is used most commonly in real-time operating systems. The mailbox architecture has a mailbox server and a mailbox client. The thread or the process which creates the mailbox is called a mailbox server, and the thread which subscribes to the mailbox is called a mailbox client. So this word subscribe is a very important term related with mailbox. So any process which want to get some information with another process should subscribe to the mailbox. A thread or a process or a task which wants to send a message creates a mailbox for posting the message, and the threads which are interested in receiving the message will subscribe to this mailbox which is created by the server. Now let's see how it functions. Here we can see the basic mailbox working. We can see a task 1 which has created a mailbox, and task 2, task 3 and task 4, they can subscribe to this mailbox. So whoever has subscribed to the mailbox will receive the message from the task 1. Now, the mailbox creation, subscription, message reading and writing, they are achieved through application programming interface calls or API calls. Now, what is API? It's a set of functions and procedures that allow for the creation of application which can access the data and features of other applications or operating systems. So they are tools which the programmers can use to create software, and they will specify how software components would interact. I will give you an example. Like in your smartphone, there's a camera and there will be already camera APIs which are there. Now I can use these camera APIs to develop my own application. So I can use these already predefined APIs to explore and use them so that I can create new apps. And that is what an API is. So the mailbox creation, subscription, message reading and writing are all achieved through already existing APIs which are supported by the operating systems. And we can find that the mailbox and message queues are similar in the functionality. One of the minor differences in the number of messages that can be passed on from one task or a process to another. Mailbox is used for exchanging a single message between two tasks. And mailbox associates a pointer pointing to the mailbox and a wait list to hold the task waiting for a message to appear in the mailbox. Whereas we can find a message queue can handle a multiple number of messages. So mailbox can handle a single message, whereas message queues can handle multiple messages. Now the implementation of mailbox is operating system dependent, and micro C OS2 implements mailbox as a mechanism for inter-process communication. So we have seen what a mailbox is, what's the architecture, and how it functions. Here we will wind up the discussion of the first three methods. That is, we saw pipes, message queues, and mailboxes. We will continue with the rest of them in another video. Thank you.